that is mechanics of solids. Since all of you are working persons, you might have most of the basic things are not in your mind. So today I come with the somewhat basics of mechanics of solids. And this is my plan. This is my teaching plan. By means of this plan, I am going to complete the portions. I assign nearly about 60 hours to complete the syllabus. First of all, introduction is there, then review of free body diagrams, then axial loading analysis by simple shear and pressure we have to analyze. Then we can determine these things statically, and then forces and moments transmitted by means of simple beams, then mechanics of deformable solids, stress, strain, transformation of stress and strain. All these things are problematic ones. So here, these much things are problematic up to here. So if we are going to discuss the problems completely inside the class, means we can't complete the syllabus. So what my plan is, I shall give you some questions. That means only 2 or 3 questions will be discussed in the class. And after that, I shall give you somewhat more problems as assignment. And within 2 or 3 days, I shall give you the detailed answer of that problem. So before that, you must try to complete that. After that only, you have to check. Agreed? This is how I am going to take up this portion. All of you satisfied with that planning? Okay. Then next is somewhat theory, that is material properties testing, elastic and plastic. Like those things are somewhat dealing with the theory parts. So I put theory for 3 hours. And next is group B. We are entering to group B, in that stress, strain, temperature relations are there, and Hooke's law. And I put 3 hours there. Why? Because sometimes if we spend more time on any one of these problems, means we can manage it here. I roughly require only 2 or 3 hours to complete this one, but I put these much hours there. Why? Because we want the hours when we discuss these problematic cases. Next is equation of elasticity, that is also theoretical. Then solution of thin and thick cylinder. That is also problematic, but it is much more simple when compared to the previous one. And next is stresses in beams, torsion of circular shaft and thin-walled sections. Those things are problematic. And then deflection of helical springs, like that. And yield criterion, energy method, basic elasticity equations. So these are theory parts. And next is main thing is the revision. I plan to conduct the revision by means of a question paper. And I already trained you by means of previous year's question paper questions in all these sections. Okay? So you will be trained with the previous year's question papers. But at last, I shall come with 1 or 2 question papers and we have to discuss so that you can revise all these topics. So my plan is to complete the class contents that we have to deal today, that is introduction, algebra, trigonometry, differential calculus, integral calculus, then scalar and vector quantities, moment of a force, then resultant of 2 parallel forces, like parallel forces, unlike parallel forces, and unlike parallel forces having equal magnitude, then a solution of a force into force and a couple, and somewhat problems and its solution. Today I come with the problem and solution to show you how I am going to give the problems as well as the solution. Okay. So I shall take a whiteboard to explain one by one. After that, we can go through the notes. And here the notes are in handwritten. Why? Because it is not a theory one. Lot of the problems and a lot of formulas, equations will be there. It is difficult for me to type. So that's why I make a note by means of handwritten and scanned it, and that will be sent to you. Okay? Okay. And then problems also solved by means of hand itself. Okay. Then, so we can move to the introduction, mechanics of solids. First of all, I shall give you why we learn this mechanics of solids. Why? Because if we want to design a product, a detailed study must be there to understand its forces and effects. Based on this force, what effect will be there on that product? That you have to analyze. As a basic of that, we are learning the mechanics of solids in detail. Then, we all know all the quantities that we want to measure, all the quantities we want to measure will be integrated to mainly three units. Can anyone? Will be integrated into three main units, that is length, mass, and time. Isn't it? Suppose if I want to measure something or measure the distance from Trivandrum to Delhi, that means it is the length, isn't it? If I want to measure the weight of that rice basket means that is represented by means of its mass. Then how much time is required to travel from here to here? That is represented by means of time. That means based on these three quantities, we are going to measure, and that is internationally accepted units. We call that as fundamental units. Fundamental units. It is from these fundamental units, lot other units are derived. For example, area. What is a unit? What is the area? What is the area of a rectangle having length A and breadth B? A into B, isn't it? Length into breadth. So area will be in terms of length you are representing. Am I right? Area will be represented in terms of length. That is also, what is length? Length is one of the fundamental unit there. Am I right? Area will be represented by means of length into breadth. What is breadth? Breadth is also denoted by means of length itself, isn't it? That means length L square, L square. That means what is L? L is a fundamental unit. From that fundamental unit, area is derived. And such units are called as derived units. Derived units. Derived units. Is it clear to all? I shall give you another example also, which is familiar to you. That is meter per second. That is for velocity. Velocity. That is how much distance traveled in unit second. How much distance traveled per second. That is distance is represented by means of length, and second is represented by means of time. So those things are also derived from this fundamental unit itself. Hence, velocity is also a derived unit. So, lot of different units can be derived from the fundamental units, and such units are called as derived units. Okay. Is it clear to all? Fine, fine. Okay. So we discussed about the fundamental units and derived units till now. And after that, now we are moving to Another part called as different expression of units like CGS, MKS, and SI units are there. That is centigrade system, metric system, and SI units, international system of units. So basically, we are using this SI units. For example, the force. What is meant by force? Force equals mass into acceleration, isn't it? Mass into acceleration. That is called as the force, and is expressed by Newton, capital N. Similarly, what is pressure? Any idea? Pressure. Pressure is force per area. Force per area. So what is the unit of force? That is Newton. Newton per what is area? Meter square. So Newton per meter square is the SI unit for pressure. Then power. That is work done per time in seconds. That is unit of work done is joule. Joule expressed by letter J. J by S. J by S, joule per second, can be written as watts. W, watts. So these are international systems of units. Can you say what is meant by a density? Density, that is mass per volume. Mass per volume. That is kilogram per unit of volume, length into breadth into height. That means kilogram divided by meter into meter into meter. That is kilogram per meter cube is the unit of density. Clear? So these are called as SI units or International System of Units. So these are basic things. Is it clear to all? Shall I move to next one? Okay, fine. I shall take a new whiteboard. Okay, next is regarding with the algebra. I am going to explain some basics that you all know. What is a raised to 0? Any quantity raised to 0, yes, is 1. Then next is x raised to m multiplied with x raised to n can be written as like that. Yes, x raised to m plus n. Similarly, yes, x raised to m by x raised to n can be written as like what? Yes, x raised to m minus n. Then, how can I find out the value of x if the polynomial is like this? That is, by means of an known equation, x equals minus b plus or minus root of b square minus 4ac by 2a. Am I right? Yes. So is it familiar to all these things? Okay, fine. Now, and just refreshing your memories. Next is regarding with trigonometry. Okay. First of all, I shall draw a right triangle. So this is a right triangle, and this is my 90 degree. So I shall name the triangle as A, B, and C. Which will be the hypotenuse here? Which will be the hypotenuse here? Yes. AC is our hypotenuse. Yes, you are right. And suppose this is the angle which I choose. What is sine theta? Sine theta is opposite side by hypotenuse. Opposite side by hypotenuse. Opposite side by hypotenuse. So here, which is the opposite side of that theta? BC. Yes, yes. BC by hypotenuse is AC. Then what will be cos theta? Yes, I is saying AB by AC. That means adjacent side divided by hypotenuse. Okay, that is AB by AC. Yes, right. Next is, what is tan theta? Yes, opposite side by adjacent side. Yes, opposite side by adjacent side. That is here, how can I write? Yes, opposite side is BC by AB. Or I can write that as sine theta by cos theta. Can I? Can I write like this? Sine theta by cos theta. Why? Because AC get cancelled. That means BC by AB itself. So next is somewhat other trigonometric relations also. That is sine 2 theta equals 2 sine theta cos theta. These are somewhat expressions. Sine 2 theta can be written as 2 sine theta cos theta. Then cos 2 theta. How can I write in idea? Cos square theta minus sine square theta. Cos 2 theta can be written as cos square theta minus sine square theta. Sometimes these expressions are required while doing problems. Next is sine square theta. Sine square theta. How can I find out? Sine square theta can be written as 1 minus cos 2 theta. 1 minus cos 2 theta. Similarly, cos square theta can be written as 1 plus cos 2 theta. So these are somewhat expressions based on trigonometry that you have to keep it in mind. Sin 2 theta equals 2 sin theta cos theta. Cos 2 theta equals cos square theta minus sin square theta. Sin square theta is 1 minus cos 2 theta. Cos square theta is 1 plus cos 2 theta. So that's all regarding with the trigonometry. So is it clear to all? Okay. Now I shall take another whiteboard. Next is differentiation. Usually represented by the symbol what? D by dx. Am I right? Usually represented by symbol d by dx. Am I right? Yes. Okay. Next is d by dx of x raised to n. I can differentiate that quantity like this: n x raised to n minus 1. Isn't it? Okay, just refreshing your memories. D by dx raised to x raised to n can be written as n x raised to n minus 1. Next is another one. d by dx of ax plus b raised to n can be written as how? Same like this itself, but another b is also there, and like that you have to write, that is we are differentiating with respect to x only. Hence, it will be like this, n into ax plus b raised to n minus 1 into differentiating with respect to x is a. N x raised n into ax plus b raised to n minus 1 into a. Why? Because x is only for a, b is a constant there. So this is how the differentiation of this quantity is taken place. Clear? Okay, fine. Now, I am going to find out the differentiation of a constant d by dx of a constant. What will be the answer? Differentiation of a constant, no news. Differentiation of a constant will always be 0. Okay? Yeah, okay. Next is d by dx of u into v. That is two terms which are respective of x, with respective of x. Okay. That is, we are putting the multiplication rule there. That is, the equation for multiplication, differentiation will be like this. That is, u into differentiation of the second quantity dv by dx plus v into differentiation of the first quantity du by dx. This is called as product rule. Clear? Yeah, okay, you already got there. U into dv by dx plus v into du by dx. Now, all of you can refresh your memories. All of you know this one, but since it is not under use, you can refresh it. That's all. Next is d by dx of u by v. That is dividing. That can be represented like this. V into, that is denominator into differentiation of the second quantity minus u, that is numerator into differentiation of the denominator divided by denominator square. Yes. Denominator into differentiation of the numerator minus numerator into differentiation of the denominator divided by denominator square. That is called as division rule. Clear? Okay, fine. Next is we are going to deal with the integration. Usually represented by the symbol integral. Symbol is like this, dx. Isn't it? Integral dx is a sign of integration. Then, first of all, integral x raised to n dx equals, that is x raised to n plus 1 divided by n plus 1. Clear? X raised to n dx can be written as x raised to n plus 1 divided by n plus 1. Next is ax plus b. integral ax plus b whole raised to n dx can be written as how? Ax plus b whole raised to n plus 1 divided by n plus 1. But x is also there. A is the coefficient into a. Yes. Okay. Now, integrating with respect to limits are also there. That is, it will be like this. Integral from 0 to a length of L, x cubed dx, x cubed dx. Can you can you integrate these things with the help of this equation? Can all of you can integrate with the help of this equation that we already derived? That is x raised to, instead of n, it is 3 here. It is 3 here. That means x raised to 3 plus 1 divided by 3 plus 1. Agreed? Okay. And that is from the limit of how much? 0 to L. 0 to L is there. Okay. So that you have to write here. 0 to L. That is x raised to 4 by 4 from 0 to L. That is x values varies from 0 to L. So that will be represented like this. That is, first of all, the top values, that is L raised to 4 by 4 minus, what is the lowest one? 0. 0 divided by 4. That is 0 raised to 4 divided by 4. That is, this quantity is 0. And what will be the answer? L raised to 4 by 4 is your answer. Is it clear to all? Okay. So now you can refresh your memories. After that, I am going to another one. Scalar and vector quantities. Scalar and vector quantities. So here, suppose some quantities may have only magnitude. Only magnitude. For example, density. Density. That is kilogram per mass per volume, kilogram per meter cube. So that have only a magnitude. No particular direction is there. For example, time that having any direction, only a magnitude is there. Yes, 5 o'clock, or say about 30 seconds is taken, 25 seconds is taken. Only magnitude is there. No direction is there. So such quantities having only magnitude are called as scalar. Such quantities only having magnitude is called as scalar. And those which have both magnitude and direction is called as what? Vector quantities. Vector quantities. For example, velocity. Velocity is a vector quantity because it has direction. It is moving from here to here. Acceleration, that is also have a velocity. Suppose I take 1 minute, control here. This is one object. I apply a force like this. Yes, there exists a direction for this force, isn't it? There exists a direction of force. That is, now the force is towards the right side. That means direction is also there for this force. Hence, the force belongs to the family of vector. Clear? Is it clear to all? Okay, fine. Next is how I can add two vectors. I shall take an example. Suppose one vector is like this. named P. Other vector is like this. Both are in same directions, Q. Since both are in same directions, we have to add up this one. That is, how to add these vectors is, first of all, draw a line in the direction of P, which is having the magnitude of P, and name that as A, B. This is vector P. And next, draw a line parallel to Q having the length of vector Q. See, I am drawing a line parallel to the Q itself. Okay. So these are parallel. This is parallel. And this is for vector Q. And this is C. Then the vector sum will be AC. The vector sum will be AC. So this will be the resultant, or this will be the sum of two vectors or addition of two vectors. Is it clear to all how I can add two vectors? If more than two vectors are there means, suppose one more vector is also there like this. So how can I do? A, you have to draw like this, then BC. So E, you have to draw like this, Q, you have to draw like this, then R, you have to draw parallel to the vector R, like this. Join the ends by means of a line. That will be the vector sum. That will be the vector sum. Clear? How we can find out the sum of vectors? Suppose a force of three forces are there, F1, F2, F3. Three forces are acting on a body in three different directions. That means one is in this direction, and other is in this direction, and other is in this direction. Okay. I am going to add these three forces to get the resultant force. What shall I do? I am using this principle. I draw a line having the magnitude of F1 and name it as AB. Then I draw line F2 parallel to this F2. Okay, I draw the F2 also, F2, and name it as BC. Next, I draw another line parallel to F3. Okay, name it as CB. That is for F3. I want to find out the resultant by joining the A and B. That will be the resultant. This will be the resultant. So this is how I can add up the vectors. Clear? Is it clear to all? Not happening? Yes, okay, fine. Now, suppose, what happened to others? All of you please give me the response. Okay, fine, good. Next is, suppose the two forces are acting in such a way that it is opposing to each other. That is, this is a body. Can't hear you. Oh, fine. All of you, is my sound clear to all? Is my sound clear to all? Okay, Sudesh. Okay. Okay. So I am going to explain another example, that is no audio. No audio. Is it now clear? Yes. Farha, can you hear me? Okay. Farha also has refresh the page. Okay. Okay. Let's wait for half a minute. So next is I am considering a force or a vector which are in opposite direction. That is, one is like this and other is like this. That is in opposite direction. Okay, fine. Okay, so now we are now. Can you hear me? Can you hear me? Can you hear me? Yes, yes, fine. Okay. So here, okay, good, good. Two forces are there acting in opposite direction. See, one is in this direction and other is in this direction. Then I am going to draw it by means of graphical method. See, say this is P, this is Q. So I draw the vector P like this and named the ends as A and B, and then another vector is also drawn that is for Q, that is for Q, that is parallel to Q, and named this as C. Okay. Then ACB I am going to join. That will be the difference of P and Q. The subtraction of P and Q is taking place. From the common sense itself, it is understandable that if the forces are equal, sorry, that is like this and it is like this means what will happen? The net effect will be the subtraction of these two. Okay. Net effect will be the subtraction of these two. So that can be find out by closing the open side of this polygon. Okay. Similarly, in the case of addition also, we can find out the total force or the sum by closing the polygon by means of a line. See, this is a polygon. 1, 2, 3. Three edges are there. And these three edges is now open. I am going to join by means of another line, say AC. Okay. Similarly, here also, AB and BC is open now. I am going to close by means of AC, which will be the resultant. And here the resultant will be the difference of P and Q. Why? Because that is in opposite direction. So this is how you have to perform the addition and subtraction of vectors. Clear? Okay. Okay, fine. Okay, good. Next is, we are moving to next topic. That is moment of a force. Okay. For that, all of you please take a piece of paper All of you, please take a piece of paper. This is my paper. Okay. And all of you, please place your left forefinger here on that paper. And then this is, okay, you just draw one line like this. You just draw one line like this. And all of you place the forefinger, left forefinger here. Okay, you have to take a piece of paper and then place it on a table and then place your left forefinger here. And before that, you please draw a line like this. Okay, ready? Now, what we are going to do is, you have to, with the help of right hand, you are going to pull the paper by means, along through this line. You are going to pull this paper along through this line. What will happen? This paper will have a tendency to rotate about this point. Am I right? This paper will have a tendency to rotate with respect to this point. Okay. Now we can conclude the moment. See, this is the fixed point. This is the fixed point. And the distance from, perpendicular distance from this point to the line of force is taken as x. And this force is taken as F. Then the moment will be F into x. The moment will be F into x. So the moment is the product of force and the perpendicular distance from a point to the line of force. Is it clear to all? And what happens because of this moment? Can you answer? What happens because of this moment? What happens because of this moment? It will have a tendency to rotate. Am I right? It will have a tendency to rotate either in clockwise direction or in anti-clockwise direction. Suppose I am considering another force. I am neglecting this force. I choose another force which is in this direction. Then to which side or to which rotation or to which direction it will rotate? Is it in clockwise or is it in anti-clockwise? Yes, counterclockwise, that is in anti-clockwise direction, it is going to rotate. It is going to rotate in anti-clockwise direction. Clear to all? Okay, fine. And if, listen carefully, if we are providing positive sign to clockwise means the counterclockwise or anti-clockwise will be given by means of a negative symbol just to indicate its direction. Just to indicate the direction. If you choose positive symbol for clockwise means you have to put negative symbol for counterclockwise. That's all. Similarly, you can use the vice versa also. That is, if you are putting positive symbol to counterclockwise means you have to put negative symbol for the clockwise. So is it clear to all? The sign conventions and as well as the moment of the force? Okay, fine. Now, moving to next. Resultant of, sorry, resultant of two parallel forces. Resultant of two parallel forces. Okay. So, first of all, I consider a body. This is one body. And two parallel forces we are considering. Okay. So, first of all, I consider two like parallel forces. Two like parallel forces I am going to consider. Like parallel means both the forces are in same direction. Both the forces are in same direction. Okay. So here is one force F1 and here is another force F2. And I am going to name this point where the F1 is acting, that is A, and this point is B. And this is the line of action of the force. Okay. So what will be the total force acting on this body? That will be the sum of these two forces. Yes, sum of these two forces. F1 equals F2. No, it is not said like that. F1 is sometimes larger than F2, but both these forces are in same direction only. We are considering that only. Both these forces are in same direction only. F1 is sometimes okay. We can consider or we can assume F1 is larger than F2. We can consider like that. But the direction of force is in same direction itself. That is, both the forces are acting upwards. Clear? Both the forces are acting upwards itself. Okay. Now we are moving to that one. That is A and B, two forces are acting. Total force, resultant force will be F1 plus F2. So that we know. I want to find out, next my aim is to find out at what point will be the resultant. This is the line of action of the force. At what point will be the resultant? And it will be inside the AB itself. This will be inside the AB itself. So we are going to prove that whether it is inside AB or not. Okay? We already find out the resultant force F1 and F2, but we don't know the point of action of R. The point of action of R. The point of action of F1 is known, that is at A. Point of action of F2 is also known, that is at B. But we don't know the point of action of R. So next our aim is to find out the point of action of R. So first of all, I assume that here this is my point of action of the force R. I just assume only, and this is taken as C. And I consider, in the previous case, I told you that a forefinger, left forefinger is placed on the piece of paper, isn't it? So similarly, I consider one point also. That is, with respect to that point, I am going to take up the moment. Say, this is my point. I name that point as O. Clear? So I assume that the resultant force is going to act through C, and I am going to take the moment with respect to the point O. Now, how to take the moment with respect to point O? Taking moment with respect to F1. Taking moment with respect to F1. About the point O. Can you help me? F1 into what is the distance from this point to this point? AO. Am I right? AO. F1 into AO. Okay. With respect to O, is it in clockwise direction or anti-clockwise direction? With respect to the point O, is it in clockwise direction or anti-clockwise direction? Yes, Mukundan says that it is in clockwise direction. Okay, Holtraj is also agree with that. What about others? All of you agree with that? Check here. With respect to O, you have to place your forefinger, and this is the force F1. When you pull like this, it will move like this. That is in clockwise direction it is moving. Okay. So we can conclude that it is clockwise. So I am going to give the sign convention for clockwise as negative. Okay. I am going to give the clockwise sign convention as negative. So this will be minus. That is for clockwise. Agreed? Next is taking the moment with respect to F2 about the O. Can you help me? I am waiting for your answer. I want to take the moment with respect to F2 about O. Mukundan is saying that F2 into OB. Can all of you agree with that? Yes, F2 is here. That is this one. And I want to find out the distance from O to B. That is here. Yes. That means F2 into BO. Agreed. Then, which direction? Is it in clockwise or anti-clockwise? Yes, Mukundan says that it is in counterclockwise direction. What about others? Yes, anti-clockwise. Yes, right. See, with respect to O, when I pull here, this will rotate like this. Okay, that is in anti-clockwise direction. That means it will be denoted by a symbol plus. Next is, I am taking, yes, right. Next is, I am going to take the resultant moment of the resultant force, taking the moment with respect to resultant about O. Can you help me? No, resultant, taking the moment, taking the moment. I am going to taking the moment only. That is R is acting over there and the distance is known, that is CO. Then what will be the moment with respect to resultant? R into CO. Isn't it? R into CO. And what about the direction? Is it in clockwise or anti-clockwise? Yes, Farha is saying that it is in clockwise direction. What about others' opinion? Let us check. Okay, Nirish and Paul is also typing. Let us check what is that. All of you, please think. R is acting upwards. And with respect to O, what will be the direction? See, it is moving upward. With respect to O, it is rotating like this. Am I right? Yes. It is in anti-clockwise direction. That means you have to represent by means of a plus symbol. Clear to all? Okay. Then we are now going to apply the one rule called as Verigne's rule. Verigne's rule. What is Verigne's rule? That is, the resultant moment will be equal to the sum of can you hear me? Can you hear me? Can you hear me? Okay, fine. So next we are going to apply the Verigne's rule. What is Verigne's rule? The moment of the resultant will be equal to the sum of moment of forces acting on the body. Sum of moment of forces acting on the body. That is called as Verigne's rule. That means the equation will be like this. R into CO will be equal to the sum of moment of forces acting on the body. That means F1 into AO and who have a negative symbol plus F2 into BO. Am I right? According to Verigne's rule, the moment of the resultant will be equal to the sum of moment of the forces acting on the body. Clear? That is called as Verigne's rule. Now, I am going to put the value of R in terms of F1 and F2. I am going to put the value of R in terms of F1 and F2. Can you help me? What is R? Resultant force. Yes, resultant force is equal to F1 plus F2. Am I right? The resultant force equals F1 plus F2. Isn't it? So that I am going to put over there. That is F1 plus F2 into CO equals minus F1 AO plus F2 BO. Like that I got. I am going to expand and rearrange this equation. And I got F1 into CO and AO is there. I take that in one side. Okay, that is AO plus CO equals F2 into BO is here and here the CO is there. When CO comes to this side, it will become minus BO minus CO. All of you agree with that? Any problem in this arrangement? All of you agree with this one? Any doubt in regarding the rearrangement? Okay, fine. Now I am going to make it short. AO plus CO. Let us see what is AO plus CO. I am going to take the figure. AO, yes, A to O plus C to O. That means this much distance will be what? AC. This much distance will be AC. Yes. So I am going to rearrange that AO plus CO as AC. F1 into AC equals similarly F2 into BO minus CO. That also we are going to rearrange. BO minus CO. This is B and this is O. And this is C, this is O. BO minus CO. What will be the net effect? The net effect will be this much. Isn't it? Yes, BC. So that can be written as BC. F2 into BC. So F1 into AC equals F2 into BC. In short, I can write like this. F1 by F2 equals BC by AC. So from this, it is clear that C is inside AB itself. C is inside AB itself, isn't it? So if the forces are like, that means if the forces are in same direction means the point of action of the force of the resultant Okay. My internet connection is disturbing me. Okay. Can you hear me now? Yes. 1 minute. Let me change my connection. Please wait. Fine. So F1 is proportional to what? 1 minute, I shall change my color. Okay. 1 divided by AC. Agreed? F1 is proportional to 1 divided by AC. See here, F1 is proportional to 1 by AC. Let us check what is the significance of AC there. From this figure, it is clear that AC is the distance of the point F1 to this much. Isn't it? Point F1 to the point where the resultant is acting upon. Yes, that means if the force F is more means, what will happen? This distance will also be more. Sorry. If the distance F is more means, this distance will be what? Less. Am I right? Because it is inversely proportional. Inversely proportional. If F1 is large means, what will happen? This AC will comes down. That means the resultant will be near to the larger force. The resultant will be near to the larger force. Clear? Mugundan is typing. Is it clear to all? What happened? Can you hear me? Okay. Okay. So here, by means of that relationship, F1 is proportional to AC. I shall draw that figure once again. This is F1 and this is F2 and this is resultant R, and this is A, this is B, and this is C. From this relation, I got that F1 is inversely proportional to AC. What is AC? The distance of the force F1 from the resultant is AC. And how it relates, or what is the meaning of this one? If the F1 is larger, means AC should be smaller. Am I right? That means what? The resultant will be acting nearer to the force which is larger. Yes, R will be near to F1. Yes, you are right. That's all. So this is how we can find out the resultant of two like forces. Resultant as well as the point of action of two like forces. Like forces means what? The forces which are parallel to each other. Is it clear to all? Okay, fine. Now we can find out the solution for this one by means of another method also. Let us discuss that method also. 1 minute. So here F1 is acting like this, F2 is acting like this, okay, and I assume the resultant will be here R like this, and I am going to name A, B, C. Now I am going to apply the principle of equilibrium. First, in the previous case, I put the principle. Can you name that principle? Varignon's principle, isn't it? In the previous case, I put the Varignon's principle. Now I am going to put the principle of equilibrium. That means the sum of the moment will be zero. The sum of the moment will be zero at a particular point or from a particular point. Okay. Now I am going to take the moment with respect to A. I am going to take the moment with respect to A. Agreed? All of you ready? I am going to take the moment with respect to A, the point A. So what will be the moment of F1? Moment with respect to F1 will be how much? What is the distance? F1 into 0. Am I right? We are going to take the moment with respect to A. So that means how much distance is there for A to get that F1? That is 0 distance. That is at point A itself F1 is acting. So the moment of F1 at point A is 0. Clear to all? So where we stop? Now we are moving to use another Principle, that is principle of equilibrium. That is the sum of moment will be equal to 0. So I am going to take, okay, I should take a new whiteboard to explain this thing. So this is the line AB, and the force F1 is acting like this, and R is acting here, and F2 is acting here. And I am going to name this as A, B, and C. According to the principle of equilibrium, the sum of moment will be equal to 0. Okay. So here, taking moment of forces with respect to the point A. Okay, that is our aim. So, with respect to the point A, what will be the moment of the force F1? Moment of the force F1 will be what? F1 into the distance from A. Distance from A is how much? It is 0. Am I right? Am I right? Okay, fine. Next is moment of, yes, resultant force R with respect to the point A is how much? R into AC. Yes, right. R into AC. And please give me the direction. Is it in clockwise direction or anti-clockwise direction? Yes, Mukundan is saying that it is in counterclockwise or it is in anti-clockwise direction. Can all of you agree with Mukundan? Yes. Okay. That means we are using a plus symbol. Next is moment of force F2 equals how much? Please help me. Yes. F2 into AB. All of you agree with that? Direction? Direction? Clockwise or anti-clockwise? Yes. Counterclockwise. Yes. That means that is also positive. Then I am going to add all these things. Okay. F1 into 0 plus R into AC plus F2 into AB equal 0 according to principle of moment. F1 into 0 is 0 itself. So from that it is, I can write it like this, that is F2 into AB equals R into AZ minus R into AZ. Okay, I can draw it like this. And here, from that, it is clear that AC should be less than AB. Why I conclude like that? Because these two are same, isn't it? In magnitude. These two are same in magnitude. That is F2 into AB equals what is R? F1 plus F2. F1 plus F2 into AC. Here, this side, this F1 plus F2 is much more large. So that AC should be much more less. Then only these two will be same. Then only these two will be same. Okay? So in that sense, we can say that AZ should be less than AB. That means C is a point within the line AB itself. C is a point within the line AB itself. Hence, also we can prove that if the forces are like, the resultant will be nearer to the largest force and will be inside the line joining F1 and F2. Clear to all? Is it clear to all? Okay, fine. What about others? All of you, please give me the response. If you have any doubt, you can ask me now itself. No problem. Okay, fine. Mugudan, Nidhi is okay. Jagannathan is okay. Then Yashi is also okay. Okay. Polraj is okay. What about others? Farha. Farha, are you there? Then, okay. Satyendran. Okay. Mukesh. Now we are moving to another part, that is resultant of two unlike parallel forces. Let me take a whiteboard. The resultant of two unlike parallel forces. Resultant of two unlike parallel forces. That means I have to consider a body like this. Here F1 is acting like this and F2 is acting like this. That is, both are in opposite direction and is having different magnitude and I am going to name this as A and this as B. Same procedure we are going to follow. In this case, one thing is that, okay, first of all, here it is named as F2. F1 is larger than F2. I am considering it like this. And according to the assumption, the resultant will be out of AB and is nearer to the larger force. That means, the resultant will be here. I am assuming this be the resultant point C and the force is acting in the direction of the largest force. So here I consider or I assume the point C is the resultant. And here what will be the resultant? R equals F1 minus F2. Agreed? All of you agree with this one? R equals F1 minus F2. Why? Because both are in opposite direction. This is in this direction and this is in this direction. Okay. Agreed? What happened? Any doubt? So here we are considering two unlike parallel. This is in this direction and this is in this direction. Okay. Agreed? What happened? Any doubt? So here we are considering two unlike parallel forces. That means two parallel forces but opposite in direction. One is upward and other is downward. Then the resultant force will be what? The subtraction of these two forces. We already discussed when we discussed the vector case. Here the force is also a vector which are in opposite direction. Then the resultant will be the subtraction of these two, F1 minus F2. And why I take F1 first? Why? Because here I assumed F1 be the larger one. Got it? All of you, is it clear to all? Now I am going to move forward. What happened? Can you hear me? Can you hear me? Yes, okay, fine. Next is, I am going to find out the moment of these forces with respect to a point O. Just similar to the previous case. Say, suppose this is the point O. Please help me to find out the moment of force F1, F2 are with respect to point O, taking moment of forces with respect to point O and apply Varignon's principle. Varignon's principle. Can anybody say what is mean by Varignon's principle? Not hearing. Is my voice clear? Is my voice clear to all? Okay. Mugundan, please refresh your page. So, our aim is to find out or taking the moment of the force with respect to the point O and apply the Varignon's principle. Can you help me or can you explain the Varignon's principle? Mugundan, is it clear now? Okay. No response. Okay. Can you help? Can you help me to? Can all of you help me to explain the Varignon's principle? What is Varignon's principle? Jagannath is typing. Let us see. Moment of resultant force will be equal to the sum of moment of the forces acting on the body. Yes, all of you is typing. Let us see. Mukesh is also typing. Okay, so the moment of the resultant force, that means what? The moment of the resultant force, that is R into CO. R into ZO equals, help me, the direction is in, the direction of R into CO is in clockwise or anti-clockwise? Yes, clockwise direction. So I am going to put a negative sign. Equals. Next is F1 for the force F1. F1 into AO. Agreed? F1 into AO. What about the direction? Clockwise or anti-clockwise? Yes, that is also in clockwise direction. That is, I am going to put a negative sign. Next is plus F2 into BO. Shall I put the plus symbol? Any problem? Is it minus or plus? Yes, minus. Why? Voltage is saying that it is minus sign. Can anyone justify? Yes, it is also in clockwise direction. See, this is also in clockwise direction. Yes, so this is negative itself. So all the things are negative. So it will get neutralized. That is R into CO. Yes, yes. Equals F1 into AO What is Mukesh? Okay, okay, that's right. F1 into AO plus F2 into BO. I can draw it like this, isn't it? Then I am going to expand R. F1 plus F2 into 0 equals F1 AO plus F2 BO. Okay, then F1, I am going to rearrange this equation. F1 into CO minus AO. That is, this one is come to this side and then equals F2 into DO minus DO, F2 into DO minus CO, isn't it? One thing, can you find out a mistake here? I have mistaken in some places. Can anyone of you find out that mistake? What is the value of R? Is it F1 plus F2? F1 minus F2. Since here we are applying unlike forces, that is in opposite direction, isn't it? F1 minus F2, we are there, it is there. So I mistaken that as F1 plus F2. That's why it is not solved. That means here this is F1 minus F2. Okay, F1 minus F2. So F1 into CO minus AO and next is minus F2 CO. That means when I come to this side, F2 into BO plus CO. Like that it will appear. Agreed? Any problem? Any problem in this rearrangement? Now I am going to find out what is CO minus AO. CO is this much. Minus AO minus this much. Then what is remaining? AC is remaining. Yes, Paul is right. So AC is remaining. So I can write that as F1 into AC equals F2 into BO plus CO. What is that? BO, that is this much, plus CO, that is this much. Yes, that means BC, this much thing. BC, yes, right. BC, F2 into BC. So from this also we can determine that F1 by F2 equals BC by AC. F1 is proportional to 1 by AC. Here F1 is the larger force. Okay, and hence the distance from the point C to F1 will be small and it is nearer to the larger force like this. See, from this it is concluded that R will be nearer to the largest force and that distance will be less. But when with respect to F2, that distance will be much more. And here we can conclude that it is out of line AB. It is out of line AB. So this is the resultant of two unlike parallel forces. Two unlike parallel forces. Clear to all? Is it clear to all? Okay. Okay, fine. Fine. Next is one more item is also there. regarding the resultant, that is the resultant of two unlike parallel forces that we already know, but of equal magnitude, but of equal magnitude. That is written there. Okay. So if such two forces are acting on a body like this, F1 and F2 with respect to the point A and B, means both having equal magnitude, means what will happen? Think F1 is acting like this, F2 is acting like this. What will happen? It will rotate, isn't it? It will rotate in clockwise direction. Am I right? Am I right? If F1 is of equal magnitude is acting like this, F2 of equal magnitude is acting like this, means it will freely rotate, and that is called as coupled. That is called as coupled. So two unlike forces having equal magnitude result in formation of a couple, and moment of a couple can be find out in such a way that F1 into AB or F2 into AB, F1 into AB or F2 into AB. Why? Because F1 equals F2. Clear? The moment of a couple can be written as F1 into AB or F2 into AB. So, in short, I can conclude that the resultant of two parallel and unlike and equal magnitude forces, that is like this, F1, F2, like this, F1 and F2. Then both having equal magnitude. So what will happen? It will rotate. It will rotate. Okay. So that is called as couple. The moment of a couple can be written as F1 into AB or F2 into AB. Clear to all? Clear to all? Clear to all? Okay, fine. So I know you get bored a lot. So this is my last topic. After that we can wind up. Shall I proceed? Okay, fine. Next is a resolution of a force into a force and a couple. Resolution of a force into a force and a couple. What is mean by a couple? Can you help me? What is mean by a couple? Voltage is typing. Yes, resultant of two parallel unlike equal forces. Yes, two unlike parallel equal forces. Yes, right. Two parallel unlike equal forces with equal magnitude form a couple. Yes, right. Yes. So here I consider a force. This is A and this is B. And I consider a force F is acting like this. F1. F is acting like this. So my aim is the solution of one force into a force and a couple. Okay? The solution of a force into a force and a couple. Let us see how I am going to proceed. Next is, I simply put, this is A, this is B. I simply put equal and opposite force at here. Any problem? If I put it like this, it will be similar to the first system itself, isn't it? The second system is same as that of the first system, isn't it? First system itself, isn't it? Because I put equal and opposite forces here, which will get neutralized. Which will get neutralized. That is similar to the first case itself. Agreed? Okay, Jagannath is okay. What about others? Confirm. Okay, okay, right. What about others? This one keeping Farha. Okay. Nidish. I think they are offline. Let us see. Yes, okay, fine. Next is, I am going to take these two forces. This one is here and this one is also here. I consider these two forces which are unlike and equal in magnitude, which are unlike and equal in magnitude. So I can resolve it like this. A, B, one force is there and one couple is there. Can I? Can I? See, this force acting at A is in this direction, B is in this direction. That means couple is formed. Two parallel unlike forces. That means couple. Then this force is also remaining. So that is also remaining. So this is same as that of this one. So hence I can resolve a force into a force and a couple. I can resolve a force into a force and a couple. Once again, I shall explain. First case is A and B. First of all, the force is acting at A. F1. Now, I assume two forces at B in opposite direction. Equal and opposite forces. Say F1 itself is acting. Any problem? No problem. These two forces get neutralized together. Then, after that, I take these two forces, which forms a couple. Why? Because these are parallel and equal in magnitude and unlike also. Okay. So hence it forms a couple. So A, B, F1 at B will be there and a couple in clockwise direction is also there. Clear? This is how I can resolve a force into a force and a couple. All of you clear? Is it clear to all of you? Okay, fine. Now we can conclude the class. That is, what are the topics that today we learned? Firstly, we explain what the units, fundamental units. Then we explained the derived units, isn't it? Then we discussed about somewhat regarding with the algebra. Those things are familiar to you. Next is we are discussing about trigonometry. Next is we discussed the differentiation, product rule and division rule also we explained. Next is we discussed about integration. Next is what we discussed the scalar and vector quantities. Can you explain what is maybe a scalar quantity or difference between these two? Can you explain the difference between these two? Yes, the scalar quantity have only magnitude, but in the case of vector, it has both magnitude as well as direction. Yes, right. And we discussed about vector sum and vector subtraction. How that vector sum is, yes, magnitude and direction is called as vector. Yes, right. Scalar with the direction is vector. Okay, yes. Say P is like this, Q is like this. So how can I find out the sum? That is, you have to draw a line parallel to P and parallel to Q by joining like this and close that or close that polygon by means of a line. That will be the resultant. If it is in opposite direction means what is the answer? It will be P minus Q. If it is in same direction means it will be P plus Q. So that's how the running with the sum on the difference of the vectors. After that, we discussed the moment of a force. Moment of a force. What is that? That is with the help of an example of a piece of paper, we discussed that. That is, a point is there, yes, and a line of force is there. The distance from this much to this point, that is vertical distance, you have to measure up. So, in short, I can say that the product of the force and the perpendicular distance from the line of action of the force to the point is called as moment of the force. Agreed? Then, what will be the unit then? Can you give me the unit of moment? What is the unit of force? What is the unit of force? Unit of force? Yes, Newton. Yes. And the unit of this distance is meter. That means moment. The unit of moment is Newton meter. Clear to all? Next is. Okay. After that, we discussed the resultant of two parallel forces. Case 1. Two like parallel forces. Then what will happen? It will be inside the line of action, isn't it? Inside the line of action. And what will be the resultant? R will be F1 plus F2, isn't it? Am I right? Then what will be the case 2? Case 2, two unlike forces. Two unlike forces. In that case, the point of R will be out of line of action of F1 and F2. And the resultant will be F1 minus F2. Yes, right. F1 minus F2. Then case 3 is two unlike parallel but having equal magnitude. Then what will be formed? A new term arises. What is that? Yes, coupled. Coupled. What is the moment of a coupled? Moment of the coupled, that is corresponding force F1 into that distance or F2 into that distance. Why? Because F1 and F2 both are same there. Okay. Next is we discussed about how to resolve a force F1 to a force and a coupled. That also we discussed. So these much topics we discussed today. Is it clear to all? Okay. Yeah, are you satisfied with this class? Or I have to improve anything? Shall I proceed like this manner itself? Okay, thank you. So, okay. So I shall come with somewhat problems also. I shall show you the note. That is that whatever we discussed today is in the note. That note will be uploaded in the site. That you can get it from the news forum. Okay, where is that? 1 minute. Yes, yeah. So the second page is that is introduction that we discussed today. The fundamental evidence, algebra, trigonometry, that everything that we discussed are here. Then the differentiation is there, integral calculus is there, scalar and vector quantities are there. Then moment of the force is there. The resultant of two parallel forces, case 1, case 2, case 3, etc. are there. Then applying the principle of equilibrium, how can we find out, that also we discussed. Then two unlike parallel forces having unequal in magnitude, that also we discussed. And next is two unlike parallel forces which are equal in magnitude also is there, that is couple is formed. Next is resolution of a force into couple, force and a couple, that is also there. After that, I come with two problems there. Shall we do it now? Is it to include your board notes? Yeah, whatever thing we discussed in the class will be in that note that you might have seen here. Okay, then. Okay. So, shall we proceed with the problem, or we have to stop today? Shall we proceed? Yes. Okay. Okay. Fine. Very simple. Two problems are there. We have to spend 10 minutes. Let us see. From next class onwards, I shall give you some work break also. After 2 hours, I shall give you some work break. Since it is a first class, I plan to complete by means of 2 hours. Okay. Three like parallel forces, 100 Newton, 200 Newton, 300 Newton, are acting at the points A, B, and C respectively on a straight line ABC. The distance are AB equal 30 cm, BC equal 40 cm. Find the resultant and also the distance of the resultant from the point A on the line ABC. I shall take a whiteboard. So here we have to consider, first of all, we have to draw a line. And A and C I wrote there. At a force is acting, at C, a force is acting, and one more point is also there. At B, another force is acting. Let us see what are the dimensions given there. Once again, I am moving to the question. That is 100 Newton, 200 Newton, and 300 Newton. 100, 200, 300. AB 30, BC 40. Okay. I am moving to the whiteboard again. Okay. So at A, 100 Newton force. At B, 200 Newton force. At C, 300 Newton force. And AB is at a distance of 30 cm. And BC is at a distance of 40 cm. This is our question. We want to find out the resultant, and the resultant, the point where the resultant is acting upon. Okay. And I assume that point to be x, or that distance to be x. That I have to find out. So How can I find out the resultant here? All the forces are parallel and like. Am I right? Yes, Mugundan is giving me. It is sum. Yes, yes. So the resultant equals F1 plus F2 plus F3. That means our first condition, case number 1. If the forces are parallel and in same direction, that means like forces. That means 100 plus 200 plus 300. That means 600 Newton. I got the answer like this. Next, so the first one satisfied. Next one, I have to find out the x. Can you help me? I am going to apply Varignon's principle. Varignon's principle. Can you apply? All of you please try it. All of you must have a calculator and a piece of paper before entering into the class. Okay? Yes. R into X, okay, equals AX into F1. Okay, like that he is writing over there. Okay, what Mugundan is writing is absolutely right, but X is an unknown quantity there. So if we depend upon X means it will be very much difficult for us to perform. Okay, because in that what Mugundan right is right, but X is on the left side and X is on the right hand sides also. So it is difficult for us to find out. So it is better to take, instead of taking the moment about the X, it is better to take the moment about a point A or B or C. First of all, I am going to take the moment about A. Moment about A. Then what will be the answer? Moment about A, as I am going to take. That means R into X. That means distance of that resultant to the point A. That is unknown. The resultant of, suppose the resultant is here. Suppose the resultant is here. Suppose. And this much distance is taken as X. Agreed? R into X equals. What about the resultant of force at A? 100 into 0. Am I right? Then, what about next one? B. In which direction? It is in anti-clockwise direction. So this one is also in anti-clockwise direction. So I put the positive symbol itself. Okay. So plus. What about B? B force is 200. 200 into, help me, 200 into 30 cm. Plus. What about the C? C is 300. Okay. 300 into, how much is the distance from A? 70. Is it clear? Now you can see that only X is unknown. What is the value of R? 600. 600 X equal 0 plus 6000 plus 21,000. Clear? Then from that I can find out the value of X there. That is how much? 27,000 divided by 600. That is so much centimeter. Be careful in writing units. We are putting the values in centimeter now. So your answer will also be in CM. Yes, 45. So is it clear to all how to perform this problem? Okay. Next one is also one more problem is also there, but I will not explain that in the class. You have to do it yourself, and you can ask me if any confusion is there in the next class. Okay, like that we are going to practice. Sorry, this is not 1 minute. Yes, this one. See, same thing, but somewhat different. Okay. Okay, one more thing is also there. That is the resultant of a determine the resultant of system that you know. Equivalent system to A. That means the resultant force and sum of all the moments about that point that you have to find out. Okay, first of all, you please read the question and try to perform it. After that only, you have to go through the solution. The solution is here, down itself. How to perform that problem is clearly explained here with all the steps. Okay. So please don't go through that solution first. First of all, you please read the question and try to do that by yourself. After that only you have to go to the solution. Agreed? Okay. And in this class, the solution is also along with this note. But by next class onwards, it will not be like that. I shall give you 5 or 6 questions. You have to try it at home. After learning this theory and with my examples, with the examples that we discussed in the class. After that, within 2 or 3 days, I will send the solution. Then you can cross check it, whether it is right or wrong. And if the confusion is remaining, you can come and ask me when you come on next class. So we can stop today. And happy Republic Day to all.